Hello, hello, hello. Welcome back, guys. Today is Wednesday, 3rd of June. Today we're going to do a little debrief because it's been a while since I've last seen you. And since then, we've had both Physics 2 and Math 1. So I just wanted to give some time to let people join. And I think I really liked it when we did that last time with the after Physics 1, sort of having a little debrief. Let me pop in the Discord server, actually. Because I think I gave an update. Oh, I didn't. Oops. Let me update y'all. And mass debrief. Sorry for no advance notice. I did populate the stream, but then forgot to put it in the Discord server. Okay. So I see a couple people have joined now. There we go. But yeah, sort of nice slow start, letting people sort of trickle in. Now, I heard for a start, Edexcel physics was apparently amazing. The Edexcel physics paper too. Curious to see if anyone has any particular comments about in fact, the math 1 that was today or the physics 2 that was on Monday. So I'm going to let people kind of trickle in. It's always a slow start when I'm like waiting for chat to start chatting. But it was really fun last time. And I think actually, let me get some feedback from the Discord when people post it after the fact. Let me see if there's anything. So May 31st, when was that? That was on Sunday, so it will have been after that. Yeah, apparently a lot of people said OCR was easy, but when I speak to them, they're all getting different answers. So that was on June 1st. So that will have been for the A-level physics paper 2. General consensus for both AQA and OCR is that paper was easier, but the questions were weirder. And then, so we've seen some questions there. If you guys have any particular questions as well, from the papers that you want to discuss, absolutely feel free to drop those in chat. So going through as well, what else is there? Escape velocity in terms of potential. Hello, it's me. That's a very loud, very enthusiastic saying of my name. Oh, math was so bad. Here we go. Tell me everything. What happened? Because the physics was, the general feedback was good. It was the worst thing imaginable. Oh, God. Let me see. What board are you? Are you Edexcel or UOCR? Let me see if student Twitter is popping off. Have you seen the mock papers for Edexcel? No. Edexcel, ooh, that's interesting. That is very interesting. Bad why? What were the questions? Edexcel's normally very good. Could that screw anyone over that I know? Let me check with my other students. Hold on a minute. Usually the mock papers for Edexcel are harder than the normal past papers. Okay. AQA math paper 1. How did the AQA go? First half was good. Second half was really hard. Okay. Interesting. All right. Now, so if this is consensus across the board, then luckily everyone's in the same boat. So the grade boundaries are likely to be a little bit lower. You were super happy with physics paper 2, literally polar opposites. Because normally physics paper 2 is the bad one. Normally physics is the one that's like really difficult to do well in. Okay, so I'm genuinely, do you guys like, okay, so what were the questions that were really difficult in the Edexcel then? So Edexcel, let's see if I can find any commentary on this. So Edexcel Maths Paper 1 reaction. You thought both paper 1 and paper 2 for physics were good, so you're worried about the grade boundaries and the paper 3. Yeah, paper 3 could end up not being fun. You tend to like student room. Let's see what student room thinks. There's normally some quick reaction on that. Oh wait, no, that was last year's. Maybe this year isn't popping off yet. Let me try to type it out so you can see. Absolutely, that would be great. There was a differential which was a bit ugly, apparently. I want to see about this reaction. Let me see if there's anything from today. No, I think it's probably a bit early for today. So, okay. Okay, let me go to the Miro whiteboard and write this out. Maybe I'll be able to give you some clarity. So if I move this across, let's go Miro. Opening up the streaming whiteboard. Okay. So let me zoom in. All right, let's get this shared. Let's start giving you guys some clarity on what some of these questions were. So I'm seeing differential equations. So dx dt equals t into a plus t squared. And you're saying when t equals 0, x equals 0.3, something on the lines of t equals 4, x equals 21. It may not matter the exact numbers, but let me give some clarity on that. So first thing I would do is multiply that out. And then that is just, you just integrate that. So it's the integral of at plus t cubed, which would be a half at squared plus a quarter t to the 4 plus c. You can plug in your boundary conditions to work out your c, which is going to be 0.3 actually. Because when t equals 0, you plug that in, x is 0.3, t is 0, t is 0 plus c. So your equation for x ends up being, oh wait, it was just x, a plus t. Well, that makes it even simpler, to be honest. Because if it's just that, then if that's not squared, this becomes squared, that becomes squared. So then this would become a third t cubed. Either way, the c still ends up being 0.3 or whatever this initial value is. So you would get x is equal to, no wait, you're just fumbling. Which one is it? So just, yeah, a half a t cubed plus a third t cubed plus 0.3. And then you would plug in the second values to work out the value of a. Brain is fried, sorry. So there's no t. If it's just this, then it ends up being even simpler still, I think. So if it ends up being that, then it ends up being at plus a half. There was an x in there somewhere. Okay, we got this, guys. 4th time's the charm. This is live. This is how we work. All right. We are going to get there. But it sounds like this is now a separable differential equation. Definitely this. Okay, right. Final answer. Final answer. So we've got dx dt. If dx dt is equal to x into a plus t, this is a separable differential equation. So we end up saying that the integral of 1 over x dx would be the integral of a plus t dt. So this would be ln x, and this would be at plus a half t squared plus c. You can plug in your boundary conditions and get that ln of 0.3 equals 0 plus c. So then this becomes ln x is equal to at plus a half t squared plus the ln of 0.3. So then ln x minus ln 0.3 is at plus a half t squared. And that matters because then I can bring this all into a single ln. That's not 10.3. What am I doing? Nope. 0.3. So that's at plus a half t squared. And then we can take, well, I suppose now we can put, either way, with these numbers, we can put in, I'm going to use the numbers that you got given to see if we can find a. So when x is equal to 21, then you would have the ln of 21 over 0.3 equals 4a plus 8 when t equals 4. So 21 divided by 0.3 is just 70. So 70 would equal to e to the... No, what am I doing? We want to solve for a here. So that would be ln 70. And that thing minus 8 all over 4 would be equal to a, which would give you a value that you can plug back in and then use as required. So yeah, just like a normal separable differential equation there. So let me stop sharing. Let's get some other commentary here. Now that you've said that, I really want to get student Twitter involved. So I'm going to be the absolute worst here, and I'm going to go on my phone because I do not have Twitter on my computer. I don't think. No. Cancel. All right, so let me just check real quick. So going here, I'm going to search for Edexcel. Level Math 1. Let's see if any reaction comes up. There was also an interesting proof on the last page you didn't see. No! The second you think you're done with the paper, check to make sure you've answered every part of every question. Ah! I'm sorry, man. That one really hurts. That one really hurts. I've been there, though. Oh, my God. So let me tell you the story of why I say that. So it was an Edexcel mechanics paper. Like, I went through the entire paper just fine. There was one thing with like a ball on a slope, I remember. And then I was like, all right, I've smashed this. I have loads of time. And so I went back to the beginning and I started checking. And I was like, going through like smashing this, getting this all right, absolutely nailing it. And by the time I get to the end, I get to part D and I realize, oh my God, I haven't put anything on part D because part D, like there was a huge diagram for part C, block text, and then D was a single line right underneath it, under which I had just started writing in black ink. So I just didn't see it. It was camouflaged between the question and my answer. And it was a 7 marker to basically redo the entire question, but with like a new situation. 7 marker, and I had like 2 minutes left on the clock, and I couldn't do anything about it. So yeah, it burns. It was a 7 mark. I missed a 7 marker. Yeah, a 7 mark part of a question. So I feel you. I feel you. It hurts. But hey, whoever wrote that maths A-level paper needs to go sit themselves in a corner. Anyone doing A-level math Edexcel paper 1 has made me genuinely suicidal. What the actual F was that A-level paper? I hate Edexcel. So yeah, I think Twitter's on your side, man. Twitter's on your side. Student Twitter is with you. The proof was 4, so not as much as that. Yeah. How many people in school got it? Further math was easier. That's interesting. I actually did hear that as well. Yeah. The core peer papers were not too bad for the Edexcel this year. Now that's also going to screw a lot of people over because especially if a lot of offers will be like A star double A, but the A star has to be in math. So what you're going to have to do is to just like really, really turn out for paper 2 and paper 3. because I think for a lot of you guys, the A star in math is the one that you need. So math is the crunch point. Now, what realistically, if you got an A in math, but you got an A star in further in physics, I think that would balance out. They would probably still let you in. Which, by the way, top recommendation on results day, do not open your results first. Open UCAS first. Because it's entirely possible that you can miss your offer but still be given your placement. So yeah, just definitely open UCAS first, because if you've got your top choice of uni, then you have nothing to fear. Then you check your results, because then, and this actually literally happened to one of my students last year. She's now in Oxford doing engineering. I'm pretty sure she missed her offer though. So if she had checked her results, she would have been like, oh my God, I did badly. And oh my God, I've missed my offer. And she would have been panicking and then gone to check and then been relieved. Checking UCAS first means that you just don't have that moment of panic. So it does happen. Missing your offer is not the end of the world. You can still go. They might still allow you. So UCAS first, then results. Now, also, I think psychologically, if you've got a bad paper one, what you don't want is for it to put too much pressure on your paper two and your paper three. So making sure psychologically you've got your head in the game so that you're not like jittery and like sort of collapse under the weight of paper two, right? So paper two, I think, is going to be really important for you to sit down, use your multiple pass strategy, get a good idea of, the first question really sets the tone. And make sure you pick a good first question that gives you that confidence and momentum. Only do the questions that are giving you that confidence and momentum that builds a story of like, oh, this is a good paper going well. Then you can go and like sort of mop up the rest of them, but you feel like you're earning that kind of like safety net. People sit at 3 a.m. updating UCAS before results day. And that's a good point. I actually don't know when they put it on UCAS firmly. But if it just don't be too much of a morning person. Just lie in. But the first thing you do is always check UCAS. You're saying it's rough. Hoping you can get paper two well, because didn't think you'd have a lot of work to do for math. I know, because a lot of people, especially if you do further, you just assume that paper one is going to go well. I would say exam technique is going to be really important for you, and checking technique, right? Because what you're going to have to do at this point is achieve your absolute maximum full potential, which means no small execution errors and no exam technique issues like missing the question like you did. So remember, the second you think you're done with a question, before you move on to the next one, make sure you've actually answered the question. Make sure you've actually got over the line. The second you think you're done with a paper, check the paper, reread it to make sure you have answered every part of every question. Then from there, you begin checking, especially with Math 2. That's where you're going to be able to do this. Plug your answers back in. Make sure you get your clean zeros. And I've got lots of demonstrations of me doing that good checking technique, because that can help you spot little execution errors that you can mop up and really fight for every mark to try and make up for what happened in paper one. It's random for UCAS. You think not till 10? Oh, interesting. Because I think it surely is earlier. You'd think it would be earlier. Right, I'm seeing more people joining in the chat. Hello. Okay. You did check a few answers on the calculator, thankfully, but not all. That's fine. That'll be based on timing. Also, another thing you can do, by the way, remember that you keep going until it says end of questions. Because if it doesn't say that, you can get to the so for instance, a really common reason people don't see final questions is because you get to the final page, you answer the question on the final page, and you think you're done. A lot of people don't flip it over and look on the back, for instance. Things like that. Wait until you see end of paper. And if you're feeling extra paranoid, you can sit there with a calculator and just add up all the total marks of what you've seen and check it adds up to the total marks available for the paper. Yeah, most papers have 14 questions. It's so, when you get sort of lulled into the complacency, it's tricky. It's tricky, man. I'm sorry. I feel for you on that one. Burns. Ugh. But we can pivot into the physics if you guys want to talk about the physics. Oh, no. Yeah, make sure you've answered every part of every question. Oh, there's interesting. I really like modulus questions. So if you can remember the form of that question, I'd be interested to get into that. Because sometimes they ask for like the number of solutions when going through the different graphs, or the number of solutions of like a line intersecting a modulus, for instance. And there's one solution when it goes through the apex, 2 when it goes above, and 0 when it goes below. It was purely algebraic one, quite tricky. Interesting. Now, the other difficult thing about modulus is you say it was purely algebraic. I think any question involving modulus, you should 100% be graphing it so that you can see. Because then oftentimes with if you do it purely algebraically, you don't know for certain which branches are the ones that are intersecting. So it can be quite tempting to just say, oh, if two modulus are equal, just take away the modulus and set them equal. But that's not guaranteeing that both of the positive branches are intersecting. Like, hold on a minute. You had a line intersecting it. Oh, I see what you mean. I see what you mean. Okay, I'm going to share the Miro again. You guys can guide me. Let's have a conversation about that question. So I was seeing talk about modulus. So it was y equals the modulus of px minus q for general p and general q. So if we're assuming they were positive constants, then we know that it would be something like this, where this would be q over p, and this would be q. P and q are both positive. Okay. So this is correct as I've set it up then. So this would be your modulus. Yep. And you're saying this is intersecting k over x. Oh. So k over x might do something like this. So you're right that there would be kind of 3 solutions. Interesting. K is also positive. Then part B was the range of values of k where it intersects 3 times. Okay. The first part was to sketch the graph so that you can visualize, which I just did. So find the range of k for where it has 3 points of intersection. Okay, so what's going to happen here? So it's always going to intersect with this. Now, this positive branch would be y equals px minus q. You know that because that's the one with the p gradient, which is positive. The other branch is going to be y equals this thing multiplied by minus 1, which would be q minus px. And so what you're looking for is when there are 2 solutions to k to the curve equaling that line. So we want q. How am I going to do this? Let's lay this out this way. We want k over x to equal q minus px for these points of intersection, and we want there to be 2 points of intersection. So what we need to do is to say px minus q plus k over x would equal 0, multiply through by x, and this quadratic would need to have 2 solutions, which means the discriminant would need to be bigger than 0. So q squared minus 4pk would be bigger than 0. So q squared would be bigger than 4pk, and k would be less than, or rather q squared over 4p would be bigger than k, so k would be less than q squared over 4p. Okay. Hello, Vivan. How you doing? Yeah, that's what you got. So yeah, it's graphing always your friend and thinking about the different branches. So hopefully that gives you some reassurance. Assuming I've laid out the question correctly, like as it actually is. Okay. Because that's the thing, modulus, you can only really do it from the graph and understanding the different branches. Like it's just the way forward with modulus. But what I will say is now that paper 1's done, I can already see resources online saying, you know, what came up on paper 1, what didn't come up on paper 2. Or sorry, what didn't come up on paper 1, therefore what's more likely to come up on paper 2. Make sure you're really getting into the details of those topics in your revision, because then you're going to be much more likely to feel confident going in. With these types of questions, does the line always have to pass through one of the branches? Not if it's a straight line, it doesn't. But in this case, because it was 1 over x, there was just never a universe where it didn't intersect. Let me go back and show you what I mean. So here, there was never a universe where it wasn't going to intersect this branch on the right. So there was always going to be one. There could have been 2 solutions when this branch on the left is tangent to the k over x curve. And there could have been 1 solution if the k over x missed it entirely. But you kind of see that intuitively from sort of sketching different graphs on there. So there could have been that. I mean, granted, I didn't even draw that one very well, but if I'd done one that looked more like this, it could have been tangent, something like that. It would have met only once, or it could have been something like that. So it was either going to meet twice, once, or no times. You could also, because sometimes they ask about modulus graphs where it's like, one of my absolute favorites was where there was one modulus graph that was like this, and there was another that was like this. And so it was the negative branch that was intersecting twice. And so you needed to be really careful about that. You sometimes also get it with modulus where it's like, where again, you ask about, you have your kind of modulus graph, and then you ask about like this line where the plus k can shift. And so let me see if I can move this. So that's when there are no intersections. Hitting the apex is when there's 1 intersection, and then anything above that is when there's 2. So understanding that for there to be 1 intersection, you have to slice right through the apex. Sometimes they ask questions of that form. Yeah, they do really like to ask this with the straight line. So it's curious. That's in fact first time I think I've seen it where it's intersecting a proper curve. Like in the textbook, the worked examples, I'm pretty sure they're all straight lines. Ooh, that's an excellent point. Would you also have to write that? That is a good point. I wonder if that will have been assumed because the question tells you that k is positive, but you are right that belt and braces, so going back and seeing, putting on the board what someone's put in chat, because k is positive, you're right that k also has to be bigger than 0. So that gives a very strict limit. So whether this would be required, I'm not sure in the mark scheme. It may be there, it may not be there, so I wouldn't worry about it. So this was today's paper 1, exactly. Oh, this paper, okay, was very problem-solving heavy. Lots of questions had unfamiliar aspects. So that's definitely not going to favor people who do the rote learning. Were there many show that's? Because at least sometimes if you have a show that, you can use that in the next part. Because sometimes there's I know, for instance, with optimization problems, the first part is always like a 5-marker show that the volume equals this random thing. But then after that, it's just find the maximum volume and prove that it's a maximum volume, where from there, it's quite standard. Oh, that's another thing. There were lots of blocks if you couldn't do earlier parts. That's bad, man. Oh, you threw the segment area pick in the Discord generator. Can you have a look? Okay, so segment area. Okay, so based on this picture, I'll transfer this to the Miro board. Did you need to find R1 or R2 in this? Oh, Dylan, was R1 twice as big as R2? That's interesting. So the bottom point is the origin. Okay, let me get into the Miro board again. Let me transfer this across and see what's happening here. So it looks like we have a semicircle centered on the origin. It looks like we've got I mean, I haven't drawn this very well at all, but it's like there's something there where that is theta, where that point then splits this into R1 and R2. Yeah, we're talking about A-level math paper 1. Absolutely. AQE math was quite nice. Okay. Oh, you have to prove some random nonsense. Most of the show that didn't tell you the coefficients, so you still have to work it out. Okay. Right, so this was the radius. Oh, I can see what's happening here. Okay, so R1 is going to be equal to a half R squared theta minus a half R squared sine theta. And R2 is going to be the same thing, but this angle is pi minus theta. So that would be a half R squared pi minus theta minus a half R squared sine of pi minus theta. That's really ugly. So we need to prove that P sine x plus Qx minus 2 pi is 0, something like that. Now, I'm going to take it from what I was given in the question that R1 is twice as big as R2. Now, how would you, the first thing I want to look at is this. So let me draw a sine graph to work out what's happening there. Or rather, no, I'm going to, because I don't like graphs, my brain doesn't see them very well. So I'm just going to use my compound angle formula. So that's going to be sine cos minus cos sine, which you can get from your formula book. Sine pi is 0, cos pi is -1, so that's just equal to sine theta, which I should have known actually from, yeah. So that is a half R squared pi minus a half R squared theta minus a half R squared sine theta. So putting this together, if R1 is twice R2, so assuming those numbers are correct, then this is twice that. So it would mean that a half R squared theta minus a half R squared sine theta would equal double this, which just gets rid of all the halves. So R squared pi minus R squared theta minus R squared sine theta. So moving this over, that would be 3 over 2 R squared theta. Moving it plus a half R squared sine theta minus R squared pi would equal 0. And then dividing through by the R squared, I get something that's like a half sine theta plus 3 over 2 theta minus pi equals 0 for the numbers that I was given. But that's for these numbers, right? Because this is a 2 pi and this is just a minus pi. So I think the numbers you gave me might not be 100% accurate. Because if we doubled this up, then then P would be 1 and Q would be equal to 3. Oh no, wait, that does work. Let's double both sides. Minus 2 pi equals 0. And then that does work. Okay, so that would mean that P is equal to 1 and Q is equal to 3. Okay, that works. But again, you're right. These are okay if you're really, really confident on the core skills of how to find the areas of like segments rather than sectors. But then you're right. You have to lay it out, piece it together. You have to be quite methodical and structured in this problem solving. And it's not very intuitive. You're right. This is not a fun paper. I'm gonna, mind you, I'm not gonna be able to see it for another couple of years, because they keep them under lock and key for next year because they just become your mocks, basically. Which is also probably why I should not be making these public. Oops. Yeah, sign errors, big execution error, sign errors. I would say, yeah, nothing to be done for the work that you've done now. I would say, remember that if you do make little execution errors like that, if you're flipping a sign, then that's gonna not cost you that much. Oh, you're right. TikTok will 100% leak them. I don't know how. Actually, do you know what? I know a guy who snuck a paper out. Not like yeah, he snuck a question paper out and then took a photo and sent it around after the fact. So it obviously didn't help anyone cheat, but it did disseminate it immediately. Although they yeah. I don't recommend. Don't be the one, because they can, as they're collecting them from the desks, if the question paper is not on your desk, they know exactly who took it. So don't be the one, but maybe benefit from having seen it from other people who leak it after the fact. If you are in year 12, do not attempt to cheat, because I can almost guarantee that these papers will be your mock. Maybe they won't make you sit both papers, but they'll kind of splice together the two papers. So yeah, year 12s, kind of behave yourselves. Now, there's obviously been a lot of talk about math, because math is the one that happened today. If people did want to talk about the physics from Monday, also still happy to do that. I'm happy to take this. Again, this is really your time. You can take it and do what you want with it. I know a lot of people, especially when you come out of exams, really want to debrief and settle and kind of refocus for the next one. So kind of looking ahead, I see Edexcel for the mechanics is on Friday. We've got Physics 3. Is that right? Oh, Physics 2 is on Monday. Apologies. So Physics 3 is on Monday. A-level Math 2 is next week. And then, yeah, your physics is all done by next Monday. And then it's all straight ahead with the math. You've got your Math 2 next Thursday. Some of you have your further mech on Friday. And then it's just a long gap between, if you're doing further mech, you've got discrete on the 16th, and then your stats and mech is until the 18th. So you've got time to turn it around on the stats and mech in particular. Make sure you, well, I think for a lot of you who thought that it would be fine to not be okay with your large data set, for instance, in your statistics, maybe, and your sampling methods, maybe now is the time to start panic revising those if you think the paper one didn't go so well. Oh, someone's got STEP tomorrow. God damn it. I forgot they put STEP in with all the A levels. Good luck in STEP. May you have an easy paper. No, may you not have an easy paper. May you have a difficult paper that's only difficult in the topics that you happen to like and can handle very well. So you do them well and everyone else fails them. Apart from the other people that I like. But yeah, no, good luck. Is it step 2 or step 3? Because I know they got rid of step 1. Also, yeah, what are you in for? Is that who still takes step? Is that Oxford or is that Cambridge math? Because Oxford's got the MAT test. No, they've got rid of the MAT test in favor of the TMUA. Oh man, well yeah, we'll see. That's the thing with papers that are kind of controversial. Their Marmite is like, you really don't know where the grade boundaries are going to land. Like if some people do well and some people do badly, it makes it really difficult to predict. Then if everyone says it was bad, then you kind of know, and if everyone says it was good, then you kind of know. Oh, is it stream buffering? Are other people having this issue? I think that's coming into effect this year with the TMUA thing. Yeah. I am curious to see whether they'll eventually give up on STEP, because I know they got rid of step 1 entirely, and they've already introduced the TMUA, which is quite mathematically advanced, and they're interviewing you. So I don't really see why they need to keep doing STEP. And it's just a really mean thing to make you do in the middle of your A levels. So we'll see if they carry on. Oh, for year 13s this year, it was still math. I think next year is the first year they do TMUA exclusive. I'm curious. Okay, so other people are getting back. I'll be curious to see this after the fact. When I watch this back, I'll see if I can see that it's buffering, because it may be that something's happening with my internet and it's sort of getting out badly. Apologies if that is the case, because I only see myself on like the YouTube window here, and I can't see anything buffering here. So what I see is not the same as what you see. In fact, what if I hold on, here's what I'm going to do. I'm going to open it on my personal account and just see if I see that on my phone. Hold on, it's Patrick Flynn tutoring. Well, would you look at that? He's currently live. So yeah, I can keep, in fact, that's not the worst idea. So I can kind of just like keep me down here. I'm not going to turn the volume on, but yeah, no, I can see it's coming through. Okay, so, okay, all good. Let's hope I've not gone green. That's funny. For anyone who doesn't get that, there was, I am so gullible, guys. Like, someone in Discord went, oh my God, Patrick, no, it's going so badly. Your camera's messing up. And they'd like taken a screenshot and like use some gidgety, widgety, who's blah, and then like changed it. And I was like, oh no, my camera's malfunctioning. And they were like, we got you. And I was like, okay, it's rude of you to, oh, you're right. That is buffering. That's a lot of buffer. Sorry, I got distracted by my own flailing in my peripheral vision. But yeah, no, I got severely. Because if you want to get me, my gullibility, because I'm so naive about technological things, that's how you're gonna get me. It's you. You are the problem, sir. Oh, I did miss your messages above. Apologies. Let me go in and find those. Ah, yes. Sorry to distract. You wanted to hear if I had any resources to find projects, things to work on and mention in your personal statement for a competitive Oxbridge application. You're applying for engineering science. Okay, you're right. You 100%. If you're going for engineering, you need to have some projects in place. These do not have to be fancy internships, work placements, none of that. A good personal statement does two things. It demonstrates true intrinsic motivation and the conscientiousness to turn that into action, right? So you're going to want to demonstrate that you have a good theoretical fascination with the ideas underpinning mechanical engineering or whatever engineering you're going for. You want to show you are genuinely interested, and you want to show that you've done something about it. So you want to say, oh, I built this little thing, and here were the engineering requirements, and so I built this thing to achieve these aims, and then I tried it, and it went badly, and I looked at why, and then I corrected it. Those are going to be what you want to do. To prove that because Cambridge, especially if you're going for Oxbridge, they want people who don't need to be spoon-fed. They don't want people who they need to drag through the degree. You're going to want to show that you can kind of hold your own, right? And so by showing, oh, when I'm interested in this thing, here's what I do about it, it gives them the sense that you're going to be someone worth investing in that way. So you're right that you do need some projects, but you would be wrong if you think you need some sort of fancy work placement. That's not it. Any resources you could share that would be worth it? I would say a personal statement just tells a good story. So there was a really good personal statement, because I do some work with personal statement editing, and I remember someone last year told a really good narrative, because she was kind of doing. She had her perspective was engineering, but with like a biomimicry angle. So she spoke about being fascinated by paper airplanes when she was a kid, and then she went and got her like small plane license. So she's like flying little planes. And then, so she kind of turned that into action and like got her license. But then she was interested in the ways that our engineering is mimicking like bird wings. And so she made those comparisons and started making a bunch of comparisons between engineering, like engineering that you see in the world and like biological structures. And I'm pretty sure she then spoke about like, oh, I did this internship and I did these things. So you do want to undergo some projects, but I think having an angle, having like a cool theoret, because also like it is your chance to sort of, it's the first time you really get to go like, oh, this is my little niche. This is genuinely the little part of this that I find really interesting. And what you do with that when you get that kind of like fascination. So hopefully that helps. So catching up on chat for a bit. Oh yeah, that's a good point actually. So there's a few websites like Enrich Maths and I Love Engineering that have nice problems That's more for dealing with interview, I think, than personal statement. So you're saying that you've seen a lot of successful personal statement examples that detail certain unique projects that bring in interesting concepts. Yes. So project work for engineering, I wouldn't say if you were going for anything other than engineering, you would not need big projects. But for engineering, yes. Some of these projects seem super niche. They don't have to be niche. That's a misconception. So I had one guy last year I did a personal statement for. He had two projects that he talked about. One was it wasn't that niche in the sense it was a self-watering plant where there was some sort of sensor, and I think it would like it might have had a light dependent resistor, so it could tell when it was sunny, and depending on the resistance, or it had some sort of sensor in it which told you something, and then based on that value, it then watered the plant. And I think he also had like a sort of burglar alarm thing where there was like an IR beam, and it like when it got broken, it could tell whether there was that it was being broken, so that there was a theoretical intruder, but also based on like how quickly it restored, it could tell whether they were walking or running or something. It was a bit weird. So that was weird. But I think you just want any sort of project that demonstrates that you know what you're talking about and you're genuinely interested. Biomimicry is cool. Someone made a model of a wing in CAD. Some coding things. Honestly, but as well, like I would not have gone in for engineering because I'm not practical. I'm not mechanical. I don't want to put these things together and build these things. So it would have self-selected me. I would have been out. I would have been chopped. But yeah, a lot of the engineering, like, have a project, but it doesn't need to be on a grand scale. It can be on a small scale. Even if it's as, like just building things around your house to solve specific problems. Like, oh, it's really annoying. This door wasn't closing. And so I made this thing that would make it close properly. Like that counts, right? Anything that's like, I see problem, I fix problem by building thing. Have just any example of that in your real life that you get to draw on. And also, I would say you don't need to be that fancy with it because, like, they see through training. They see through, like, oh, I went to this super fancy private school, which means my school had a robotics club, which is why I did this project. They're like, okay, cool, but you got brought through that, right? Personal statement is meant to be about you going above and beyond what you're given. And so I think like a very basic engineering project from a state school that's completely unsupported carries as much weight as doing some cool robotics thing when your school has a robotics lab. Like, it's not, you don't measure in the absolute like that. So yeah, that's my advice on that. You feel like some projects are a bit iffy because if you come from a less fortunate family, you can't afford to substitute the projects, right? But I would say you can do projects on no money. You could do projects. You could like, there are people who like fly tip bookshelves, and you could be like wood bet, or like you could do something with like you could do the sort of spaghetti bridge experiment, like sort of working out how to build different bridges and how a triangle is the best shape and work on these different structures. You can construct bridges using spaghetti. How much is a pack of spaghetti? Like, these things count. So I don't want you to feel that like the cost was prohibitive. You don't need to have been like, oh, I interned at this super cool company because my dad knew someone in the company who got me in. Like, the trust me, the emissions people can see right through that. So it levels out. Yeah, so you're saying you've worked a lot on let me check because I've got a session at 5, so I have to make a hard stop there, but I'll keep chatting in the meantime. So you've worked on a lot of stuff in simulation, which reduces costs significantly, yes. So are computational projects also worth mentioning? Completely, because again, two things: true intrinsic motivation and the conscientiousness to do something about it. That counts. You can do projects absolutely like the two I mentioned. Couldn't build anything physical because of the financial barrier. Yeah, okay, that's fine. But I think yeah, I think that's quite cool actually. The fact that cats, because so you were saying, I remember from the chat, you were saying you built a wing in CAD or something like that. So that counts. That's project. That's like doing something and like, because it takes a lot of grit to get to the end of a project, right? That's the bit they want to see. Oh, back onto the physics. So paper physics 2 was chill for OCRA. Chem paper 1 was bleh. I can discuss the chem. I'm not very good at A-level chem, but theoretically speaking, I know some of the ideas. But yeah, so the physics, yeah, I haven't heard a lot of people complaining about the physics. AQA physics, like for 2022 to 2024, was actually evil. But it seems like they've calmed down. They've kind of learned their lesson now and recalibrated to give people an actual opportunity to do well. Hold on, let me move you guys over here so I can be looking more at you while I'm also looking at the chat. Right, so on the basis of that, it seems like math was a mixed bag. So lots of problem solving, lots of hard stuff. Hopefully that is a sort of good omen for paper 2 being easier. But it does mean if you feel like you're on the back foot, definitely put the work in between now and paper 2 and paper 3 to really like smooth out any of the cracks, right? Do all of the little things that you might have let yourself get away with not doing if things had gone a little better. Do the large data set, do your sampling methods, do the annoying things, look for the niche things. If it is in a worked example, it is liable to come up. So definitely make sure you've like got everything on lock. Make sure you've got your execution really strong. Make sure you know, like, you're careful and strategic about not making these little sign errors, and make sure you're nailed on with your checking technique, which is going to be much more important in paper 2 than paper 3 if you're in Edexcel. If you are an OCR, then you still have some pure in both papers 2 and paper 3, so your checking technique can still raise you up there. You're saying you feel the same way. Your physics is stronger than chem. You low-key thought OCRA physics was easier than that chem paper. So I think math 1 seems to be the one that's got people. Everything else, it seems like you guys are still doing well, moving through the exam campaign as you should. I'm trying to think, is there anything else? You guys let me know if there's anything else you need to cover, or else I'm going to start winding this down now because I've got 3 minutes left till my session. So it might be good to have like a little bit of a break. I think you guys now know what you got to do strategically, right? Based on what's happened in paper 1, how to make your adjustments. Keep me posted. As always, the Discord is available if you want to drop suggestions for me to cover. So I have been going through the OCR MEI paper 3s, the mathematical comprehension, because those are difficult and fun for me, and there's not a lot of resources. But if you think there's something more useful for me to go through, maybe a bit more seminar style for the math, because I've mainly just been doing the papers rather than like seminar stuff like I've done for the physics. If you think there are specific topics you want me to just focus on, drop those in the help or the streaming suggestions in the Discord. I can make sure to cover those. Yeah. Link to the Discord server. It's in the description of every video. Maybe not in the description of this current video because I don't do the descriptions until afterwards, but it's in my channel description. It's in the description of any video. It's open access. Anyone can join. In fact, why don't I do that now? Actually, no, I don't have the link. I'm technologically illiterate, but but it is there. It is very, very findable. I will make sure it's there. And you're right. I should probably preemptively put it into the description of any stream so people just have that while live. Thank you for that suggestion. That's one of the things you can put in the streaming suggestions channel. All right, you guys. In the meantime, feel free to drop anything in there if you want anything covered. I'm next planning on seeing you guys, I think, on Monday for a live solve of the math. Which, yeah, that'll be right after your physics paper 3 as well. I won't have time to do a debrief on the physics 3 on Monday. I may have time to do the debrief on Tuesday. I'm currently planning it on Wednesday, though. And so we can kind of go through anything there. That'll be right before your math 2 as well, so we can maybe some strategize. Keep posted. I post when I'm going to go live on the Discord server, and I do populate the streams in advance on YouTube, so you can see when I'm going live. If you want to make sure you want to join for something that you can kind of show up. But right, apologies. I feel like I've spoken like a mile a minute this entire time, just trying to get through everything. But it's only because I knew I had a hard stop. So I do have to go now, and I'm going to see you guys on Monday. In the meantime, keep revising, keep working hard, keep doing your best, and we'll get you through to the other side. All right, guys, take care. See you next time. Bye-bye.